fluid pressure. You submerge something in water, how much pressure is on this object? The pressure on an object at a depth h in a liquid is given by the formula, the pressure, which we'll call P, is equal to W times H, where W is the weight per unit volume. The weight per unit volume. So these objects for right now, it's at our particular height in the water. Now, what is the fluid pressure? What is the fluid pressure? The fluid pressure is equal to the pressure times the area. So pressure times the area. Okay. So suppose you have some object in the water. Suppose you want to find the fluid force on a rectangular metal, a metal sheet. Nice, thin metal sheet, rectangular shape, 3 by 4. And it's submerged in 6 feet of water. So in other words, you have, well, let me draw this better. You have this rather thin, that's important, you have this rather thin piece of metal submerged in the water. And it is rectangular shape. It is 4 feet by 3 feet. But it is known that it is under 6 feet of water. Let me just get this 3 dimensions down. It is known to be under 6 feet of water. Well, what does that mean? Well, it means it's 6 feet underwater. What else would it mean? So the water level, the water is at the top here. That's the water level. Everything beneath, water. And this distance is 6 feet. It is 6, this bottom sheet, thin piece of sheet metal is 6 feet below the water. Oh, what's the pressure? The pressure is the weight times the height. Well, the weight, the density, is 62.4 times the height is 6. Times, so that's P, times the area. Well, it's 3 feet by 4 feet. 3 times 4, 12. You multiply these 3 answers, those 3 numbers, and you say, that wasn't a bad problem. It's 4492.8 pounds. That now need to be very clear on one thing. Every point on this piece of sheet metal is 6 feet below the top of the water. Every piece, every point is exactly 6 feet. It is submerged 6 feet into the water. That is, the sheet metal is parallel to the surface. If it isn't, it's a completely different problem. We're going to do but for right now, it's parallel to the surface of the water. Now let's try another one like this. Okay. Find the fluid of a 3x3 metal sheet submerged horizontally in 5 feet of water. So you have a 3 foot by 3 foot sheet of metal, and it is submerged 5 feet into 5 feet of water. The question is, what's the fluid pressure on this object? Well, the fluid, the force on the fluid. The force on the fluid is simply the pressure times the area. But the pressure is the weight times the depth times the area of the object. Well, this is water, I said, and the density of the water is 62.4. The height or the depth of the water, well, it's submerged 5 feet. Everything should be in feet. And the area, well, 3 feet by 3 feet. That's 9. Just multiply these three numbers and say that's not so bad. 5 times 60 is 300. 5 times 2 is 10. That's 310. 5 times 0.4. 5 times 40 cents is $2. 312 times 9. Well, 12 times 9 is 108. Carry it 100. 2,700 plus one more. 2,808 pounds. That's the fluid force on this 3 foot square sheet of metal submerged 5 feet into the ground. Sorry, 5 feet deep in the water. Very standard type problems. But now that changes. What if it isn't submerged parallel to the water? What if it's perpendicular? What if you take this piece of sheet metal and you don't lie it flat, you keep it vertical and you push it into the water. So maybe the top is only 3 feet in the water and the bottom is 8 feet in the water. It turns out that the force exerted by fluid of constant weight against a submerged vertical plane from y equals c to y equals d is given by the force is equal to the weight times the integral of h of L times, I guess it's L of y times dy, as y goes from c to d. H of y. If I said h of L, I was joking. Now, h of y is the depth of the fluid at y. How far is it? How deep is it at y? If this is the water level, and you call this the y-axis, and for whatever reason, you put 0 there, and this is, say, 2. All right, negative 2. Yeah, it's probably better to call positive y down here. And you're talking about the height along here, y. How deep is that? Well, the answer is it's y minus 2. If, of course, you call 0 right at the height of the water, if you let y equal 0 right at the water, well, then this height down will just be y. It'll be y. H of y, if you label, you put the axes in an intelligent way, h of y is just going to be y. Now, what's L of y? Now, you don't have to have a rectangle here. You don't have to have a rectangle here. What if you have a triangle? L stands for length. At that height y, how long is this? At another height y, how long is this? That is, I need to know how long those lines are for any given h. For any given y. When I'm 2 feet deep, how long is the horizontal distance of the object I'm putting in? When I'm 3 feet deep, how long is the horizontal distance of the object that I submerged in the water? I need to be able to say that. That's going to be the whole problem, finding out what L is. Okay. Now, suppose I put in an isosceles trapezoid. So here's the water, and I put in a that's the water level, the height of the water, the surface of the water. And I put in an isosceles triangle. I meant to say trapezoid. I put in a isosceles trapezoid. And I tell you that the top is 8 feet long, and the bottom side is 6 feet tall, or 6 feet long. And I tell you that the height of this trapezoid is 5 feet, and one more thing. How deep is it in the water? And let's say it is 5 feet. And I want to know the fluid force on this object. What is the force exerted by the fluid on this trapezoid? Okay. So the first thing you should do is you should put a coordinate system. I would always let the x-axis be right at the surface of the water. Some textbooks might call the positive y-axis on top, but I'll put it on the bottom. Okay. Now, I pick some y value. I'll call it y. You know, we really should call it y star. The students have a fit when you call it y star. So the force is equal to the density of the water, we're putting water in, times h of y. Well, if I'm at y star, how far into the water am I? Y. H of y is just y. Now, the question now is, how long is this? It's not a constant. At this y value down here, it's a bit shorter. At this y value, it's a bit shorter. So, what I would do is, I'd find the equation of this line. Oh, one other thing. this y-axis cut that trapezoid in half. That is, this piece is only 4, and it's down 5. This point here, x is 4, and y is 5. What about down here? Well, if the whole base is 6, this is only 3. And let's see. First I went down my 5 feet, and then, I went down another 5 feet. So this is 310. You know what? Just not to have 5 twice, how about I change one thing? It's 4 feet deep. That is, the top of this is only 4 feet into the water. That would make that point not 4, 5, but 4, 4. And the bottom is 5. You went down 4. No, it's not fine. And then you went down, first you went down 4, and then you went down 5 more. You're at 3, 9. So I want to find the equation of that line. I want to find the equation of this line. Well, I have 2 points. The slope is, well, if y goes from, the slope is a change in y, is a change in x. And if y goes from 9 to 4, it went down 5. And if x goes from 3 to 4, it went up 1. That is, the slope is negative 5. So y is equal to m, which I now know, times x plus b. I need to find b. I'll use the point 4, 4. When y is 4, x is also 4. So 4 is negative 20 plus some number. The number is 24. You owe somebody $20. You owe the bank $20. You deposit $24. You have $4. That is, b is 24. So I go to the line right above that, and instead of plus b, I write plus 24. That's the equation of the line. Now, I want to know how long x is. I want to know how long x is. I want to know how long, given some point y, I want to know how long this is. In fact, I'm going to double it to find out how long the whole thing is. But for right now, given some height y, I want to find x. So I want to solve the equation of the line for x. I'm going to interchange these two. Right now, I have 5x is 24 minus y. And then I divide by 5. That's what x is. It's 24 minus y over 5. Now remember, the horizontal distance, or the length, I call L. L of y is twice x. It's 2 times this. It's 2 times 24 minus y over 5. It's 2 times that. L of y is 2 times 24 minus y over 5. I can put the 5 that way. Times by. Okay, and what's y going from? Now y is only where this trapezoid is at. Y is 4 here, and maybe it's 4 and a half, and 5, and 7, and 8. And it goes down 5 more. It goes from 4 to 9. It goes from 4 to 9. Just find the y values in here. What's the range? Goes from 4 to 9. So I'm going to integrate from 4 to 9. Okay, let me get a lot of this stuff out of here. And we'll do the calculus. We'll use integral. First thing is I'll bring out the 2/5. So it's 2/5 of 62.4, the integral of 24y minus y squared dy. 2/5 of 62.4 times the integral of that is 12y squared minus y cubed over 3. And y goes from 4 to 9. So we have the constant 2 times 62.4 over 5. And now I plug 9 in. So I get 12 times 9 squared. Now, when I plug in 9 cubed, I have 9 squared times another 9. Well, that 9 divided by 3 is 3. Minus, now I plug in 4. This is 3 times 4, times 4 squared. 4 times 4 squared is 4 cubed. 3 times 4 cubed minus 1/3. Dividing by 3 is 1/3. 1/3 times 4 cubed. I hate doing calculations, so I try to make it as easy as I can. I'm hoping things will actually cancel out very nicely. So now I have 2 times 62.4 over 5. I have 9 of these. Think of 9 squared as x. I have 12x minus 3x. I have 9x. 12 minus 3 is 9. Times 9 squared, 9 cubed. Minus, I am subtracting 4 cubes. 3 minus a third. Think of 3 as 9/3. Minus 1/3 is 8/3. I have 8/3 of 4 cubed. And if you calculate all of this, you will get 13,936 pounds. The math you do your way. Okay, definitely, my job, in my opinion, is to get you up to this. How you plug in the 9 and how you plug in the 4, the limits, to get the numbers, that's between you and your paper. My job is to get you that far. Okay, and I'm showing you some really nice tricks. You don't have to do all these calculations. Stop using a calculator. Okay, that finishes that problem. Let's try one more problem. Suppose you have this triangle. Submerged 3 feet, at least the top is submerged 3 feet. In other words, here's the water level, and here is a triangle, like such. This part is perpendicular to the water. It is 9 feet long, this is 6 feet long, and it is 3 feet deep. Some of it is 12 feet deep. This down here is 12 feet under. 3 feet, and then 9 more feet, total of 12 feet. The question is, what is the fluid force on this? What is the force exerted by the fluid on this object, on this triangle? And we know that and it has water. It's W times the integral of L of y. Well, let me say H first, like I've been doing. H of y times L of y times dy. Now, what is L of y? That is, if I pick that arbitrary point, how deep is it? Well, if I call this the x-axis, and I call this the y-axis, and down here, I call that positive y, well then that height is y. That height is y. 0, 1, 2, 3, 4, 5, y. Okay. So this is, the weight is 62.4. H of y is y. Now, what is L of y? The question is, how long is this? How long is that? Well, once again, I find the equation of this line. I know this point, I didn't go any left or right, x is 0, and I went down to 3, but down is positive, 0, 3. How do you get to this point? Well, first, you go down 3 and then 9 more. You go down 9, and then you go to the right, 6. It's 6, 9. So, I want to find the equation of this line. Well, the slope is the change in y. From 3 to 9, went up 6. Change in x. From 0 to 6, it went up 6. The slope is 1. The slope is 1. So y is equal to 1x, which I'll write as x, plus b. Oh, okay, so I'll use this point. When x is 0, y is 3. 3 is equal to 0 plus 3. B is 3. B is 3. So instead of b that I'm erasing now, I will put 3. Now, I didn't see this initially, but when you have 2 points, you really should spend just a moment or two to think, do you see the equation? Can you think of something that you can do to both of these x values? One rule that you can do to both of these x values to get those y values? And the answer is yes. If you take the x values and you add 3 to them, you will get y. 0 plus 3 is 3. 6 plus 3 is 3. If you add 3 to the x, you will get y. That way you don't have to find slopes and y-intercepts. You just read it off. Y is equal to x plus 3. Okay, let me write that down. There's only one problem with all that. It sounded sweet and nice, but that height is not 9. This height is not 9. I think I said it nice and cleanly, but then I goofed. I didn't write it down. To get to this point, you go down 3, and then you go down 9 more. You went down 12. Sorry about that. Let's find the equation of the line by first finding the slope. You go from 3 to 12, you went up 9. From 3 to 6, you went up 6. The slope is 3 over 2. And I don't see any relationship. Like I double 6, I get 12. But when I double 0, I don't get 3. Here, well, you add 6 to x, you get y. Not over here. Okay, so now we know y is equal to mx plus b. I'll use 0 as 3. 3 over 2 times 0 is 0. You add b, you get b. Y is 3. Just recopying this, except instead of b, I say 3. Y is 3 over 2x plus b. Except I didn't live up to what I promised. B. The other thing you can say is when you have 0, anything, that's b. That's b. Okay, so we have the equation of the line. Let me erase lots of this. Now, for a given y value, I want to know what x is. For some given y value, what's going on here? For some given y value, I want to know how long that is. Solve this for x. Bring this to the other side. Y minus 3 is 3 over 2x. Multiply both sides by 2/3. Multiply everything by 2/3. The right side, 3 over 3 cancels, 2 over 2 cancels, I get x. 2/3 y minus 2/3 times 3. The 3's cancel, 2/3 y. The 3's cancel, leaving 2. That is, x is 2/3 y minus 2. That's L of y. That's the length, is 2/3 y minus 2. 2/3 y minus 2 times dy. So I found h of y, which is, in my opinion, always get it to be y. And L of y is a little bit harder. The whole job is to find L of y. Now, what is y going from? Since I drew on this picture so much, let's draw it again. Let's find out what y is going from. We have the positive y-axis. We have the x-axis. And then you have the triangle, like such. This distance was 3, and this distance is 9, and this distance, it doesn't matter. And there's the positive y-axis. Okay. So what's going on? Well, where are these horizontal lines actually inside the object that we put into the water? And the answer is from 3 and then 9 more, from 3 to 12. 3 to 12. The object, some of the object is 3 feet under the water. Some of it is 3.001 feet in the water. Some of it's 4 feet in the water. Some of it's 11 feet deep in the water. And some of it's 12 feet deep. Going from 3 to 12. Okay, so you get 62.4. You distribute 2/3 y squared minus 2y dy. 62.4. This will be 2/3 times y cubed over 3, or 2y cubed over 9, minus the integral of that is simply y squared. Y goes from 3 to 12. And then you plug in. I'll call this 3 times 3 in the bottom, as I mentioned. I'll call it 9. Okay, so you have 62.4. You plug in 12. You have 2 times 112 times 12 squared over 9. 3 goes into these numbers 4 and 3 times. So you have 8/3 times 12 squared minus 12 squared. 112 squared. Minus, you plug in 3. You have 3 times 3 squared. 1 3 on top kills the 3 in the bottom. You have 2/3 times 3 squared. Minus, you take away 3 squared. Okay, you have 62.4, and you're playing games with 12 squared. How many you have? You have 8/3, 12 squareds, and you're taking away 1, 12 squared. 8/3 minus 1 is 5/3. Minus, you have 3 squares. You have 2/3, 3 squares, you're taking away 1. 2/3 minus 1 is negative 1/3. Negative 1/3 times 3 squared, or 9. This, of course, becomes plus. Everything is over 3. 62.4 over 3. You have 12 squared is 144 times 5. 720, if I'm not mistaken. Plus 1 times 9. 729. Okay, I got 29,952. 29,952. Okay, how you calculate the how you do your arithmetic, that's up to you. I'm not going to tell you how to do arithmetic, but I'll show you how to find h of y and L of y and how to integrate. Okay, that finishes the section on pressure, fluid pressure. Study hard.